Think about the last sunset you saw. It was probably a familiar blaze of fiery red and orange, right? Well, on Mars, that same sun ends the day in a completely different way with a haunting, ghostly blue glow. So how can one star create two totally different light shows? The answer isn't magic, it's physics. It's all about the unique atmospheres of these two planets and how light behaves when it travels from a star through that atmosphere to your eyes. Let's take a trip from the familiar red to the alien blue to unravel one of the solar system's coolest mysteries. First, let's break down why our sunsets are red. It's all thanks to something called Rayleigh scattering. Earth is wrapped in a thick, dense atmosphere full of tiny gas molecules like nitrogen and oxygen. Sunlight might look white to us, but it's really a whole rainbow of colors smashed together. As this light enters our atmosphere, it starts bumping into all those little gas molecules. Now, blue light has a shorter wavelength, which makes it really good at getting bounced around and scattered in every direction by these particles. That's why our sky is blue during the day. You're literally seeing blue light scattered everywhere. But when the sun gets low on the horizon at sunset, its light has to travel through way more atmosphere to get to you. On that extra long trip, nearly all the blue light gets scattered away from your direct line of sight. So, with the blue light gone, what's left are the longer wavelengths, the incredible reds, oranges, and pinks that paint our evening sky. Okay, so now let's jump over to Mars. It really is a world of opposites. Earth is the pale blue dot, while Mars is the red planet. And their sunsets are just as different as their daytime colors. The Martian atmosphere is nothing like ours. For one, it's incredibly thin, about 1% of Earth's atmospheric pressure, and is mostly carbon dioxide. But the real key ingredient for a Martian sunset is its dust. The air there is full of fine, iron-rich dust particles, and that dust changes everything. On Earth, our atmosphere is all about tiny gas molecules. On Mars, it's all about this bigger, ever-present dust. Because of this, the daytime sky on Mars isn't blue. It's a hazy, reddish-pink color, because the dust scatters red light around the sky. But when the sun starts to set, that's when the real magic happens. So here's the aha moment. Remember how Earth's tiny air molecules scatter blue light away? Well, on Mars, those larger dust particles do something different, thanks to a process called me-scattering. They are just the right size to scatter red light away from the sun's direct path, but they cause blue light to scatter forward, toward an observer's eyes. As the sun sets on Mars, its light takes a longer path through this dusty air. The red light gets scattered across the rest of the sky, but the blue light stays concentrated right around the sun itself. As atmospheric scientist Mark Lemon explains, when the blue light scatters off the dust, it stays closer to the direction of the sun than light of other colors does. The result is a stunning blue halo that forms around the setting sun. The very same dust that makes the Martian sky look reddish during the day is exactly what creates that focused blue glow at sunset. So instead of a fiery red finale, you get a cool sapphire-colored sun slowly fading away. And this isn't just a theory, we've seen it. We have incredible postcards from another world. NASA's rovers, from Spirit and Opportunity all the way to Curiosity and Perseverance, have sent back breathtaking photos of these alien sunsets. These pictures confirm the science, showing a sun that looks smaller and dimmer than ours, glowing with that signature blue light as it sinks behind the Martian craters and rocks. And here's a cool side effect. All that dust floating high in the atmosphere means twilight on Mars lasts much longer than it does here. The sky can actually keep glowing for up to 2 hours after sunset, as light continues to scatter off those lingering particles. So there you have it. 1 star, 2 planets, and 2 completely signature sunsets. Here on Earth, our thick atmosphere scatters blue light away from the sun, leaving us with a beautiful gift of red and orange. But on Mars, the thin, dusty air flips the script, scattering red light away and keeping the blue light focused in a brilliant, otherworldly glow. It just goes to show how even something as simple as a sunset can be totally transformed by the world it's on. Which sunset would you rather see? Let us know in the comments. If you thought this was as cool as I did, make sure you're subscribed for more deep dives into the science that shapes our universe.